Here we go. Welcome. We're on page 74, pressure. We're talking about, got a lot of snow outside. You go walking outside, you step in it with your little shoes on, you're up to your knees. Little bird popping all around over there on top of it. Why? Because he doesn't exert as much pressure as I would. Okay? So what is pressure? Okay? The word pressure actually relates to the word press, believe it or not. Okay? If you refer to a force exerted over an area on a surface of an object, you may recall that Earth's gravity is pulling us down, okay, with a force equal to your weight. Okay, so due to gravity, your feet exerts a force on the surface of Earth over the area the size of your feet. Okay, and as Caleb mentioned, and on the next page there, it shows you your feet, average foot, is about 250 centimeters square. Okay, that's not a big area. If you multiply that by 2, you got 500 centimeters square. You take a snowshoe, which is very popular up in the northern states where they get a lot of snow. That area is about 1,100 centimeters square. By 2, that's 2,200 centimeters square of area that is being spread out. Remember when we talked about that? Why does the ships float? Okay, it's not necessarily the shape of them, although that does help, but it's because that weight is spread out over a larger area. Okay, same thing with the snowshoe. Okay, I don't weigh any less, but if I got on those great big snowshoes, now my weight is being spread out over a larger area. So I'm not exerting as much force and pressure on the snow. Okay, that's why I don't sink up to my knees. Okay, unless it was real deep. Okay. Okay. So now, basic geometry. Okay, you guys have probably seen this before. Okay. The relationship of force, area, and pressure is summarized by a formula. Pressure equals force over area. Okay? So, pressure is equal to the force exerted on a surface divided by the total area over which the force is exerted. Well, that's a mouthful, isn't it? Yeah, and it almost makes it impossible to go, huh? Okay? So force is measured in newtons. I'm going to come back to that and explain it to you in a second. Force is measured in newtons, okay? Area is measured in squared meters. Since force is divided by area, the standard unit of pressure is the Newton per square meter, okay? This unit of pressure is also called the Pascal, if you remember. Pascal, after Pascal's principle, exactly, okay? Now, what it's talking about, the area there, this is back to basic geometry. How you find an area? You measure it, right? You got to get your measurement. You go up the sides, go across the back, whatever. Width, yeah, width and length. And then you multiply it. So it shows you a picture there. If you got blocks that are 2 centimeters high and 3 centimeters in length, what would the total area be? What would it get?
6 centimeters.
6 centimeters squared, because it's just 2 times 3. Okay? So if you had an area that was 4 centimeters by 20 centimeters, what would it be? What do you think, Leo? Leo was daydreaming. He was just staring off into Never Never Land, remembering the turkeys. Actually, he's probably thinking about his new piglets.
It's 80 centimeters.
Okay. So what would 4 centimeters times 20 centimeters be? 80 centimeters, okay? How about 10, Braxton? How about 10 centimeters by 10 centimeters? What would that be? What do you think, Caleb?
That would be 100 centimeters square.
100 centimeters square. Now, if I had an area that was 10 centimeters by 10 centimeters and an area that was 5 centimeters by 20 centimeters, which one would be bigger?
10. They're the same.
They're the same. They're just shaped differently, but they're the same. They're both 100 centimeters square. Okay? Got it? Okay. Okay, don't let the math trick you there. All right, if you flip over on page 76, we have this lovely beanbag thing sitting there, okay? And it talks about how if you're sitting in that, okay, the pieces are closer together, okay? Inside, they're under pressure, so they're closer together. But they're not solid, otherwise it'd just be one of the chairs in your living room or something, okay? So they do move and they pass each other. So they're almost like a liquid, if you would. I mean, which is why when, you know, someone as big as I am sits down on it, it kind of bulges out to the side. But it doesn't go completely flat because you also have the outside pressure pushing in on you. Okay, everybody understand? So they got that outside pressure. Think about, we've talked about, okay, air. Is air a fluid? Does it fall under fluid pressure? Yes, it does. Okay? And we talked about the air above our head weighs as much as an activity bus. Okay? So why doesn't it crush us? Because it's pushing in from all sides with that same amount of force. From the bottom, sides, front, back,
So it's all
down the
equal.
top. So it equals out. Okay? Now, what makes this, come with me. Okay, what makes this happen, okay, you got the solids right here, and I'm going to take you away so they can see, okay? You got the solids right here. That's all the molecules sitting there, okay? They're packed together, and they're vibrating up against each other, but they can't pass each other because they're so close. That's what makes them a solid, okay? The top of your desk, the walls, anything that is solid, okay? They are vibrating. That's why we talk about in the summertime, this desk, if you put it out in the sun, it would get just a little bit bigger because they will spread out. Heat will make them spread out. In the wintertime, if you set it outside and really, really cold, it would come in just a little bit. Not enough that you're going to be able to go, oh my gosh, I got an extra foot of desk here. No. Okay. Now, liquid, right here, see those four? Liquid is spread out a little bit more. Okay. But they will hit each other and bounce, but they can pass each other. That's what makes it a liquid, okay? That's what makes them liquid. Gases, you might have one up here, and you might not have another one down here, okay? That's what makes them a gas. They don't, okay? So you got very attracted to each other, somewhat attracted to each other, don't like each other at all, okay? All right. So that kind of explains how these gases and all are going to be operating as we start talking about them. Yes, Mr. West.
Well, wouldn't like, I can't even represent it, how would those molecules be even, like, that space would be, like, not even this big?
Well, they're microscopic.
Yeah.
Yeah, but I can't draw microscopic on the board, so I have to, I draw big ones so you can see them. Yes, Leo.
I know this is a weird question, but is slime a solid or a liquid?
A liquid because it takes the shape
Yeah,
of a
but like,
container.
it's not.
No,
water,
quicksand.
but it's not like.
It would probably be classified as a liquid because it does take a shape.
Like that's, I don't know, but I'm just thinking.
All right, yeah, my guess is because it can take the shape of whatever you put it in, it would be
I
classified
wasn't trying to be
as a
funny, but actually that was the question.
No, that's a good question. Okay, all right. Now, solids such as sneakers are not the only material that exerts pressure. Fluids also exert pressure. Okay, a fluid is a material that can easily flow. As a result, a fluid can change shape. Liquids such as water and oil and gases such as air and helium are examples of fluid. Okay? So what causes fluid pressure? To understand how fluid exerts force, you can results in pressure. Think about a tiny particle that makes up the fluid. Okay, particles of the fluid constantly moving in all directions. That's what we just talked about. Okay, as they move, the particles collide with each other and with any surface that they meet. Okay, as each particle as a fluid collides with a surface, it exerts a force on that surface. Okay. So all the forces exerted by the individual particles in a fluid combines to make up the pressure that is exerted by the fluid, okay? So if I filled up a water bottle a plastic bottle with water, okay? Is that water exerting force on that bottle? Yes, it is. The inside of the water is exerting an outward pressure.
Because
The
it
air
wants
on
to
the outside is
escape.
exerting because it wants to escape.
Inward. It's
It
like
is,
trying to keep it
yeah,
together.
it's putting it in, okay? That's why if you empty the water out of a bottle and you take the top off of it, you can just crush it with your hands. Okay, especially if it's one of the cheap Food Line bottles that, okay? It just crushes, okay? If you fill that thing full of water, you can still squeeze it in, but you can't crush it down if you got the top on. If you fill it full of air and you got the top on.
It's because
And then you can blow into it and it'll
Yeah.
expand again.
Okay, and you can, you're right.
here.
Okay? So, air pressure. You know that you live in the bottom of 100 kilometers of fluid that surrounds the Earth. Okay? That's the atmospheric gases that makes up the Earth's atmosphere. Okay? These gases press on everything on Earth's surface all the time. So air exerts pressure because it has mass. You may forget that air has mass, but each cubic meter of air around you has the mass of about 1 kilogram. Okay? Because of the force of gravity pulling down on that massive weight, the air has weight. And the weight of the air is the force that produces air pressure or atmospheric pressure. Okay? Now, to balance it out, this is what we've been talking about. If you hold your hand out, palm up, you're holding up air. Okay? At sea level, this is pretty cool. At sea level, the atmospheric pressure is about 10.13 newtons centimeters square. Okay? The surface of your hand is about 100 centimeters square. So the weight supported by the surface area of your hand is about 1,000 newtons, which is about the weight of a large washing machine.
Is that why my hand is going?
Okay? So you're holding up a large washing machine right there. Okay? So we all know we can't run up and grab one of those heavy washing machines and just lift it with one hand and stand here and hold it. So what
That's
makes
because
it?
it's
Why?
times 2 as it's.
Because you've got that same amount of pressure coming up underneath your
crazy.
hand. Okay, so it equals out. So you're able to hold all this air up because you've got that same amount of force coming up underneath your hand that is helping to support it.
What if there
Okay?
was no air like coming down? Could we just float?
Mm-hmm. Probably. You'd have the pressure pushing you up at that point in time. Okay? It's almost like God had a plan for you. Right? Okay. So balanced pressure also explains why the tremendous air pressure pushing on you from all sides do not crush you. Okay? Your body, think about this, your body contains fluid that exerts outward pressure. For example, your lungs and your sinus cavities contains air. Okay, so that's exerting outward pressure. Your cells and your blood vessels contains liquids. So pressure from your fluid inside your body helps to balance out the air pressure on the outside of your body. Okay? So what happens when air pressure becomes unbalanced? Okay? At that point in time, things starts to get crushed. If we had one of these really cool machines here, you've got a vacuum pump, things called vacuum pumps. If you took one of the metal gas cans, okay, like a little 1 gallon gas can, 2 gallon gas can, and you took a vacuum pump and you sealed it and you put that thing in there and you turned it on and it sucked all the air out of that can and you left it going and it just kept removing air, that can would crush in on itself because the outside pressure would be so great that it would just crush that can because there's nothing inside equalizing it. Okay? So it would crush that can inward.
Wait, so then how do you, if you just have a plain can, how does it not crush?
It's got air in it.
Breathe.
So it's got air or liquid in it.
Air
all the
when
time.
it gets pressed harder enough.
Yep.
It's hard. When it gets pressed
Okay.
enough, it can be hard.
All right. Now, tell us about how a commercial airplane is about 12,000 meters. The atmospheric pressure is about 20% that of sea level. by sea level, we mean if you're standing at the beach, looking out at the ocean, you are at sea level. Okay, you are level with the sea at that point in time.
And when
Okay.
you're on the mountains, you're like a
Yeah.
1,000 feet.
Well, but how many mountains do you? What kind of beach do you go to?
No, I was just saying,
No,
sorry.
You go to a mountain.
I'm not a beach.
all right. At 8,000, Mount Everest is about 8,850 meters. It's about 30% that of sea level. Helicopter at 6,000 meters, about half that at sea level. You jump out of a plane at 3,000 meters, you're about 70% of the pressure at sea level. Okay? And of course, if you're in a boat out there floating around on top of the ocean, guess what? You're at sea level. Yeah, you're at sea level. Okay? Now, we've talked about this before also. If you dive down about 10, 12 feet deep,
You can feel the pressure.
you can feel the pressure. Okay?
The pressure is-
At just 10 meters below the surface, the water pressure of a scuba diver is doubled the atmospheric pressure at sea level. Just at 10 meters, it doubles. Okay? At 2,500 meters is about 250 times greater than it is at sea level. Okay? Now if you were able to go that deep with no protective gear whatsoever, this is where it would start to actually crush you. The pressure would actually start to crush you because you could not offset. We're talking again about unbalanced forces. Okay, you couldn't offset it at this point in time.
And yet there's
Okay.
and yet there's little fish that can survive all the way down there.
You got fish that can survive down there.
That's
You do.
because they have
Okay.
gold.
There is a reason, but think about it. Okay, first of all, you're underwater. You got the water that is pressing down on you, right? But what is pressing down on the water?
The depth air.
Air. All that air that we're talking about is above us pressing down with all that weight is also pressing down on the water. Well, then the water is pressing down, so that's why as you get deeper, you have more pressure pushing down on you. Okay, now you got the air and the water. Okay, so you got unequal forces. Okay, so that's why you can't just go somewhere and rent scuba diving gear and go scuba diving if you've never been trained. Okay, you can die if you don't know what you're doing. You can actually die. So it's very important that you're trained and know how to handle all the pressures and things. Yes, Caleb.
Wait, so how can little fishes survive all the way down there with pressure?
That's how God made them. No, there's actually probably a scientific answer.
No, actually it is, but they're built to offset that kind of pressure.
Yeah.
It is a lot to do with the way that's the way God created them.
So when he says, how does this happen?
Oh, it really is. I mean, I know that sounds like a cheap answer, but they are able to offset that pressure. They actually have bladders that will fill up and go down and stuff like that. That's how they float and things. They can actually control the amount of pressure in their bodies. We can't. Okay? All right. Now, if you ever watch the news or the weather, okay, the weather person. You gotta be political correct. Okay, the weather person. The way you measure air pressure is with a barometer. Okay, and there's different types. You've got the Android, you got the Mercury type. But what they do is they detect the change in air pressure. If you got a storm coming in, the pressure will drop. Okay. If you spend a lot of time outside in the summertime, springtime especially, you can feel if a storm is coming up and you're outside, you can feel the pressure drop. Yeah, and if you feel that drop, you know rain is probably coming pretty quick. Okay, so if you've never done that, tuck that one away somewhere this spring. When you're outside and you feel that pressure drop, go, oh, I bet it's going to rain, and see how long it takes. You might grow up and be a weather person. Bye. No homework questions tonight, so just watch the video and enjoy your day.